Hello! In this video, I'll discuss a limitation related to the LG OLEDs. I'll also show you how to render your HDR video so that it includes the proper metadata tags. And finally, I'll get into the topic of text and graphic levels in HDR. As I mentioned in the video called where I shows the C9 and CX series OLEDs, grading on a TV comes with its limitations, especially one called ABL. ABL stands for Automatic Brightness Limiter, and it's exactly what it sounds like. A limiter which won't allow the overall luminance of the panel to exceed a certain threshold. Now, at which point the ABL circuit kicks in and dims the screen is not dependent on the maximum output level, the brightest pixel, but on the average pixel level, or APL for short. To visualize this, think of a completely white screen. At a certain threshold, it can't go any brighter because of ABL. And when working on bright scenes with these types of displays, it is something to be aware of and look out for. Because if you're grading with the APL circuit activated, the content might look brighter and not as intended when played back on another display. This can also be illustrated if we raise the gain on an already fairly bright shot. When I then disable the node, you can see the brightness of the TV first get lower, then to go back up a bit, because of the ABL circuit no longer being active. Professional RGB OLED monitors, such as the Sony X300, also have this limitation, but the implementation of how they handle it is different, where instead of using an ABL circuit, the X300 has warning lights, which lets the colorist know when to back off on the brightness. Unfortunately, on these OLEDs, we don't get a warning, and the dimming just happens. The way I deal with this is to add a node which lowers the brightness of the clip. If I can see the brightness going back up again after activating the node, I know that ABL was active, and that the average pixel level needs to be brought back down for a correct representation. With experience, you'll also be able to use the waveform scopes to stay below the ABL threshold. I'm thinking that it also would be nice with a plugin or external device that measures the average pixel level, and at a certain threshold activates a warning before ABL kicks in. Let me know if you have any ideas in this regard. So, it's time to render out our HDR video. Now, as a first step, I'd like to activate the custom hard clip that we created earlier. This will make sure that there's no information rendered out that we haven't been able to see while grading, as this hard clip is set up to match the calibration and maximum luminance of the display. It's also a good idea to confirm that the hard clip is actually working by looking at the YRGB waveform monitor. I believe it's a good idea to be able to see the 3 RGB channels individually, as the Luma channel by itself doesn't always tell the entire story. To more easily see this, I also have this reference line set up at the same level. See the video managing the PQ signal to learn more about the custom hard clip and reference levels. While we have the scopes panel up, also take a look at the CIE chromaticity scope, just to make sure that the gamut limiter is working, and that we don't have any information outside the P3D65 color space. If you can't see an outline for the P3 gamut, go into the scope settings and select P3D65 as an additional gamut. Now I'm going to take a look at a few different clips to make sure that the gamut limiter is working as it should. When exporting your HDR video, it's important to make sure that the file gets the right metadata tags, to ensure that the video will be recognized as PQ HDR and played back properly. Since you're working in a color mesh workflow, Resolve automatically writes its metadata tags to the video file, although a more recent feature allows you to set these tags manually in the deliver page. So let's do that. To set custom metadata tags, go to Advanced Settings, and there you'll find options to set both the color space and gamma tags. I'm going to select Direct 2020 as the color space tag, and SD2084 as the gamma tag. These are the same settings that I have the Resolve color management configured to. Again, if I wouldn't select anything here, the tags will be automatically written to the file upon render anyways, but I feel more confident about manually setting them myself. Now, before rendering, make sure to use a 10-bit codec that's compliant with PQ HDR. I'm going to choose DNxHR HQX 10-bit for this particular render. If you're on a Mac, a high quality ProRes codec will also be a good option. So that's all we have to set up to render an HDR video. I can now add this job to the render queue and export the video. Now I want to end this video by discussing the topic of text and graphic levels in HDR. In standard dynamic range video, white text, like for example titles or credits, by default sits at 100 nits, as this is peak white in SDR. And as I said earlier, there's no fixed white point in HDR. If you're generating the titles within DaVinci Resolve, you have to create a compound clip to be able to manipulate the luminance using the grading tools. If you take a quick look at the color page, you can see that there's no graphics visible here. So I'll go back into the edit page. Right click on the text and select New Compound Clip. Enter a name for it and hit Create. If you go back into the color page, we can now manipulate the text. And if you take a look at the scopes, you can see that it also sits exactly at 100 nits. By using for example the curves, it's possible to change how bright the text will be. So, at which level do we place our text? Well, that depends. If you're talking about titles or credits, with white text against a black background, then the ITU BT 2408-0 guidelines recommend a reference level of 203 nits, which also seems to work quite well. Although, this is only a guideline, not a hard rule that you need to follow. If you wish the text to pop a bit more, try 300 nits. Now, within a program, how bright you make the text is context dependent. So if you have a very bright scene, you might want to put the text higher than 200 nits. Or if you feel that the text is too punchy, you could lower it. Sometimes the text might work best at the regular SDR level of 100 nits. Also, remember that with color, the brightness of the text will be lower than if it's plain white. In the next video, I'll get into the topic of how to drive a SDR version from your HDR grade, using the Resolve Color Management and also the Dolby Vision ICMU.